Hi students, this is our 7th lecture of electric potential and capacitors. And till this lectures we have studied about electric potential, potential due to an electric dipole, due to a point charge, thin spherical shell, etc. Also potential energy, equipotential surface, its significance and so on. And today we are going to a little bit of numericals related to the topics till we have completed. And before starting, just introducing myself. This is our channel, Physics Gallery, Asha. Okay. So, a question is written in the board. You have to read it. A regular hexagon of side 10 centimeter has a charge of 5 mu coulomb at each of its vertices. A regular hexagon of side 10 centimeter has a charge of 5 mu coulomb at each of its vertices. Okay, that is, there is a regular hexagon. What is regular hexagon? A hexagon whose side length are same. Okay, regular. Then each of its vertices contains 5 mu coulomb charge. Calculate the net electric field and potential at the center of the hexagon. Calculate the net electric field and potential at the center of the hexagon. This is the question. That is, we have got a regular hexagon. Hexa means 6. That is, our polygon contains 6 sides of same length. Okay, this is L, this is also L, 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 L. And each of the vertices contains a charge of 5 mu coulomb. This is Q, this is also Q, this is also Q, Q, Q and Q. All of the charges Q is equal to 5 mu coulomb. At first we have to find what is the net electric field. We have to find the net electric field at the center of the hexagon. So we have to take the center of the hexagon. So this is the center point O of the hexagon. Okay, at first we have to take the electric field intensity. We have to take the electric field intensity. So at the point O, the surrounding 6 equal charges provides an electric field intensity. And electric field intensity due to a point charge Q is equal to 1 by 4 pi epsilon 0 Q by the distance x square. This is the distance. Okay. And what about the structure? It is a polygon. What is the specialty of a polygon? This polygon, which is a regular polygon, all side lengths are same. Therefore, each triangle is equivalent to an equilateral triangle. Therefore, we can say this is also L, this is also L. Each and every side length are same. That's why it is said to be a regular hexagon. Okay, so X is now equal to L. No doubt. So we want the value of electric field intensity at O. Due to one point charge, it is 1 by 4 pi epsilon 0 Q by x square or L square. Okay, so we can write it as E due to a point charge Q is equal to 1 by 4 pi epsilon 0 Q by L square. It is, that is clear to you. Okay, and now how many charges are present? 6 charges. Electric field intensity is a vector quantity whose magnitude is this. Electric field intensity due to a point charge magnitude is this. And what about the direction? If the charge is positive, the point acts as negative and the direction is from positive to negative. So here the direction of the electric field due to this charge Q at a distance L from O is towards O. Okay. Similarly, this is also the same charge at the same distance. The magnitude is this itself and the direction is from positive to negative. The charge is positive, the point acts as negative. Here also the same charge, same distance, positive to negative. Direction, positive to negative. Same charge, same distance. Same charge, same distance, positive to negative. The charge is positive, the point acts as negative. Same charge, same distance. Charge is positive and the point acts as negative. It means that the electric field due to this plus Q and this plus Q are equal and opposite. They cancels out. Okay. Similarly, the electric field intensity due to this charge and this charge are equal and opposite. They also cancels out. These are also equal and opposite. They also cancels out. Therefore, we can say the net electric field at O is equal to 0. Okay, at O, at center, equal to 0. The net electric field at center is equal to 0. Is it clear? Is it clear? So what is the net electric field at the center? Is equal to 0. And this principle has a name. Can you tell me what is that name? Yes, principle of superposition. The vector sum of electric field at O is equal to 0, and this is called as the principle of superposition. Okay. And here there is a general method. If we have got a regular polygon, that is side lengths are same, then the electric field intensity due to equal charges, the charges must be equal. If the polygon is, there is a condition, a polygon which is regular. What is regular polygon? Equal side lengths. Okay, the polygon will be regular, that is of having equal side length and having equal charges at its vertices. Okay, electric field at the center will be always equal to 0. Is it clear? The polygon must be regular, having equal charges at each corner, then the field at the center will be always equal to 0. Whatever may be the polygon taken. For example, if you had taken a square, which we have already done in earlier lectures. Square, side length is same, L, 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 L. Okay. Charge Q, 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 Q. What about the field at O? These cancels out. These also cancels out. So this is a regular polygon with equal charge at each vertices. So we can say here the electric field at the center O is 0. If we take a equilateral triangle, equal charges at each vertices, what is the field at the center? Here centroid. This point, what is the field? How to take here, whether it balances? Yes, it balances. Positive to negative, the field like this, E due to 1. Positive to negative, the second field like this. And the resultant will be this. And the electric field due to this charge will be like this. This and this cancels out. Do you understood how to take the electric field of an equilateral triangle? Once more, drawing. Suppose we have got an equilateral triangle. This is our equilateral triangle. And each corner contains equal charge Q. How to take the electric field at the centroid? Suppose this is the centroid. How to take the electric field? This plus Q provides a field like this. This is the direction of E1. This plus Q also provides a field here. Positive to negative, this will be the direction of E2. Both of them will have the same magnitude. And the resultant of both of them will be parallelogram law. According to the parallelogram law, this will be the resultant E dash. Okay. So we have taken the net field due to two charges at B and C. This is the resultant E dash. And the field due to A. This is positive charge, point act as negative. So this will be the field due to A. EA and E dash will be equal and opposite. So they cancels out. So in general, we can say for any regular polygon having equal charges on its vertices, the net field at the center will be equal to 0. Okay, symmetrical condition. It is the condition of symmetry. So we have completed the first question. Calculate the net electric field is over. We have to apply the principle of superposition, and since the polygon is regular with equal charges at each vertices, we can say the net field at the center is 0. Okay, pause it and copy it. And I am going to rub. We are going to the next question. There is one more question here. What is that question? You have to take this polygon, regular, equal side length, equal charges, and so on. The net field will be 0 at the center. And the next question is, so we got electric field at O is equal to 0. And now we want what is the potential. What is the equation due to potential due to a point charge? 1 by 4 pi epsilon 0 Q by R. 1 by 4 pi epsilon 0 Q by R. And which type of quantity is potential? Whether scalar or vector? It is a scalar quantity. Whether it has any direction? No, only magnitude. So we can see the potential at O due to this charge Q. 1 by 4 pi epsilon 0 Q by L. The potential at O due to the second charge Q at the same distance. Same charge, same distance. Whether it cancels out? No, because only magnitude, no direction. So how to take potential is a scalar quantity. We have to take potential due to one charge into how many times? The same magnitude. So how many times, how many charges are placed here? 6 charges at the same distance. Equal charges at the same distance. So V total, V at O is equal to, we can write, tell me, 1 by 4 pi epsilon 0 Q by L into 6. I'm just substituting the value, you will get the value. 9 into 10 raised to 9, 1 by 4 pi epsilon 0's value. Charge is Q itself. Oh no, it is given. It is 5 new coulomb. 5 into 10 raised to minus 6 by, what is length? 10 centimeter. We have to convert it into meter. 10 raised to minus 2 meter into 6. What is the value? 5 6 are 30. 3 into 9, 27. Then 0. Minus 1. Minus 5. 10 raised to 4. Okay, 270 volt. 270 into 10 raised to 4 volt. Whether the calculation is correct? 5 6 are 30, 3 9s are 27, correct. Okay, so how much volt? 270 into 10 raised to 4 volt. So what is the net field here? 0. Because the polygon was regular and each corner contains equal charge. But what is the potential here? Whether the potential is 0? No, the potential is 270 into 10 raised to 4 volt. Okay. One more thing, suppose the charge was minus Q, equal charge, but the sign was minus Q, minus Q, minus Q, minus Q, minus Q, minus Q, minus Q. Then also the electric field will be 0 because the charges are equal. The polygon is regular. But the potential will have a negative sign also. The potential due to a negative charge will be negative. Okay, is it clear? Is it clear? So we have completed the first question. Write this. So pause the video and write it. Hoping you understood what we have studied in this question. And now we are going to the next question. While I am rubbing, you have to write the question. The question is, an infinite number of charges, an infinite number of equal charges. So we have got an infinite number of charges, an infinite number of equal charges Q, okay, are placed in x-axis, at a distance, positive x-axis, okay, at a distance x is equal to 1 meter, 2 meter, 4 meter, 8 meter, 16 meter, and so on. Okay, an infinite number of equal charges Q are placed in positive x-axis. At a distance, x is equal to 1 meter, 2 meter, 4 meter, 8 meter, 16 meter, 32 meter, 64 meter, and so on. Infinite number of charges are placed, okay, in positive x-axis. The question is, find the potential due to the system of charges. Potential due to the system of charges, where at x is equal to 0 meter. We have to find what is the potential due to these infinite charges at a point where x is equal to 0. Is it clear? What is the question? There is an infinite number of equal charges q which are placed in positive x-axis. At distance, x is equal to 1 meter. At 1 meter, there is a charge q. At 2 meter, there is again a charge q, the same charge q. At 4 meter, at 3 meter, there is no charge. At 4 meter, there is a same charge q. And then at 8 meter, then at 16 meter. Then we have to find what is the potential due to the system of charges. Infinite charges are present there at x is equal to 0. Okay. Suppose this is our x-axis, okay, and this is our origin O, 0 meter. Okay, so we have to take, this is 1 meter, this is 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 7 meter, 8 meter, 9, 10, 11, 12, 13, 14, 15, and 16 meter, and so on. Okay, the x-axis is going so on. At 1 meter, we have placed a charge q. At 2 meter also, there is a charge q. At 4 meter also, the same charge q. At 8 meter, charge q is present. At 16 meter, then at 32 meter, then 64 meter, and so on. Charges are placed up to infinity. Okay. The question is, what is the potential at O due to all of these charges? Due to all of these charges. How to take? Simple. What is the potential at O? It is equal to potential due to charge at 1 meter, Q1, plus, this is scalar quantity, simply add it. Potential due to charge at 2 meters. So we will write it as potential due to charge at 1 meter, potential due to charge at 2 meter, okay, plus potential due to charge at 4 meter, plus potential due to charge at 8 meter, plus potential due to charge at 16 meter, plus so on, so on, so on, so on, so on. Okay, this is the answer. So how to take the sum of infinite numbers? That we have to do. So potential at O is equal to, providing the value, what is the potential due to a point charge? 1 by 4 pi epsilon 0 q by r, 1 meter, plus 1 by 4 pi epsilon 0 q by 2 meter, plus 1 by 4 pi epsilon 0 q by 4 meter, plus 1 by 4 pi epsilon 0 q by 8 meter, plus so on. Okay, so taking the common together, q by 4 pi epsilon 0 is common to all of the terms. Okay, then here only 1, plus here 1 by 2, plus here 1 by 4, plus here 1 by 8, plus so on. Okay, so what is this? Your maths, tell me what is this? This is the sum of infinite numbers, GP, geometric progression. Okay, so how to solve the GP? How to take? Yes, there is a simple equation, q by 4 pi epsilon 0 into, what was that equation? A by, yes, tell me your maths topic. A by 1 minus r, where a is the first term and r is the common ratio. Okay, a is the first term and r is the common ratio. So what is the first term? A is 1 and r is 1 becomes 1 by 2. 1 by 2, 1 by 4. 1 by 4 becomes 1 by 8. So what is the ratio? So here A is equal to where A is equal to 1 and R is equal to 1 by 2. Do you understood? Providing the value, now the calculation becomes very simple. V0 is equal to 1 by 4 pi epsilon 0 Q into A is 1, 1 minus R is equal to half. What is 1 minus 1 by 2? 1 by 2. 1 by 4 pi epsilon 0 Q into 1 by 1 by 2. Or we can write V0 is now equal to 2 comes upward 2 into 1 by 4 pi epsilon 0 value 9 into 10 raised to 9 into Q. This is the value. Or we can write V0 is equal to 18 into 10 raised to 9 Q. If Q is given, provide the value of Q also. Okay. Is it clear? So we have taken 2 examples of the topic we have completed. Is it clear? So till the next video, try to do it and also try to solve more and more questions. Okay, winding up this video. Till the next video, bye.